Good morning, everybody, afternoon, whatever it is when you see this. This is Miss Summers with your notes today on urbanization. So if you're in my honors class, you are taking notes, Cornell style, focus note style, whatever you want to call it, basically where you have the two columns. You'll be writing in the right column as we go through, and then you'll go back to the left. If you're in academic, you're going to be following along with the outline provided. All right, so today we've been talking about human impact. We started by talking about how population is growing. All right, more people are being added than taken away. And then we started talking about the resources that people need. So yesterday, we talked about traditional energy, because everybody needs energy to cook food, to stay warm, to produce electricity, yada yada. And we looked at the pros and cons of each. So today we're looking at urbanization. We want to know how urbanization can impact an area. Okay, again, and just like with traditional energy, we're going to look at the positives as well as the negatives. And for the negatives, we're going to see if we can fix that. All right, so let's first define what urbanization is. If you look here in this little diagram, this fun little doohickey up here. All right, you can see that there's 16 squares and there's one person per square. Everybody's kind of spread out evenly. When something is urbanized, or when an area becomes urbanized, we condense that. So an urbanized area, is an area of growing cities and towns. All right. So if you were in Mooresville, say 20 or 25 years ago, it would look very different than it does today. It is far more urbanized today than it was in the past. All right, here's a picture taken 24 years apart. This is, I believe, Hong Kong, if I'm not mistaken. And you can see, so here's the same river. All right, you can see the expanse of buildings predominantly upward. All right. So urban areas, how we characterize them, are these two things. So there's high population density, so you have a lot of people in one area. All right, like if you go to New York City or Los Angeles, there's a ton of people in a fairly not large area. People are not spread out. And there's more human development. So when we say human development, we just mean things that, we mean buildings is what we really mean. So things like houses, commercial buildings, and roads and bridges, just like we see here in Houston. So here's your sort of urban center, your big, tall skyscrapers. There's lots and lots of pavement. Notice how very little grass there is. There's very little vegetation. All right, it's very much like over in this little pod, very much covered in pavement, and that's going to be very important. All right, so let's take a look at this graphies. How urbanization has changed since 1886. That's when this graph started. All right. So this is a population of some place, somewhere. And it had people divided based on whether they lived in an urban area or a rural area. So in 1886, more people lived in rural areas, the green there. Fewer people lived in urban. All right. And it stayed that way until about, if that thing would go away, thank you, until about 1916. So you see there on the x-axis, that's when that red bar got larger than that green bar. And every year since then, the urban population has grown tremendously, while the rural population has either stayed the same or gotten a tiny bit smaller. All right, so more people are living in cities than in rural areas for the first time in human history. More people live in cities now than they ever have before. We have switched as a society from rural, living in a place where we grow our food, to cities where we all live together and we have stuff brought to us. All right, so when you have a whole bunch of people, and if you've ever been out to Los Angeles, you can attest to this, or maybe even New York City, you can attest to this. Where you have more people, especially in the United States, you tend to have more cars. And if you have more cars, there's a demand to build more roads, just like it is here in Mooresville. All right. The big problem at the school here, all right, one of the worst parts about the school, if there's any worst part, it's trying to leave in the afternoon. Because you have a whole bunch of cars, but only one road. So you're going to create these, areas of congestion, these traffic jams, all right? So people want to solve the traffic jams by building more roads, right? That makes sense. The problem is pavement causes its own little issues. So I'll give you a moment to read that. Pavement is impervious or impermeable, if you've heard that word in biology. Impermeable. Fluids cannot pass through it. So if you were to pour a bottle of water on this road, it would just puddle up. There would just be a little puddle there. Water flows over pavement, not through it like the ground does. If you pour a bottle of water on the ground, the water would soak in, but not on pavement. Pavement also absorbs heat, especially when it is darker colored like so. All right, that's going to cause problems, so keep that in mind. Pavement is impermeable, pavement absorbs heat. All right, let's talk about the impermeable part first. Because pavement is impervious or impermeable, when it rains, excess runoff is formed. So let's take a moment and look at this little tidbit of information over here. Thought it was interesting. All right, 1 inch of rainfall on an acre of woods produces no runoff. So imagine it's raining 1 inch an hour for 1 hour. All right, all that water's going to the ground if you are in a forest. That's cool, right? That's great. All right, the ground will be squishy, the ground will be wet, but you're not going to have flooding. 1 inch of rainfall over an acre of asphalt. So if you think about like Walmart parking lots or the parking lot here at school, that's definitely an acre of asphalt. That produces 26,000 gallons of runoff. So imagine 26,000 gallons of milk, how much that is. All right, a little bit of rain can produce a lot of runoff. And if you have days where it rains for several days in a row, well, now you have a problem. This excess runoff causes flooding. Urban areas are more likely to flood than rural areas because water cannot infiltrate. There we go, water cycle word. Water cannot infiltrate into pavement. Also, any chemicals, anything that is left on the pavement is going to be carried away with said runoff. So here's a pretty picture. In a suburban area, this looks like it's in a neighborhood, where we have rainwater, and this pretty little rainbow thingy here is oil that has leaked from automobiles. Maybe somebody was changing their oil in the driveway and it got knocked over or something like that. All right, that stuff gets carried with that runoff. And this is just going into a drainage system, which is going to end up in another body of fresh water, like a stream or a lake. So this is a good example. This is a good bring back to non-point pollution. Non-point pollution, remember, is caused by runoff, which happens more on pavement because the water can't go through it. It has to go over it. Okay, so that's why the pavement, the impermeable part of the pavement, that's the problem, is it makes flooding. Our second characteristic I wanted you to remember, I'm recording a video right now. I'm sorry, I'm talking to somebody outside my door. I don't think they heard me, but it's okay. Urban heat islands. So a heat island is just what it sounds like. It's a place that is warmer than the places around it. So it's a little pocket, a little area of heat. Everywhere around is cool. Urban areas tend to be heat islands. They tend to be a tiny bit warmer than their surrounding areas. So the reason this is again, we already said this, pavement, especially dark colored pavement, absorbs heat, and that heats the air directly above it. So because the surface gets hotter, the air around it is hotter. So here we have this nice little graph. This is a fun graph. So this is late afternoon temperature, ranging from 85 degrees to about 92. In the rural areas, it's coolest. You have lots of trees, lots of shade, lots of vegetation. Right, remember that water evaporates through plants, through transpiration. That helps cool down the air too. Suburban, you have a little bit more pavement, but you still have some vegetation to keep things cool. All right, imagine walking outside barefoot, all right, to go get the newspaper or whatever. You probably want to stay on the grass where it's cooler as opposed to walking on the concrete or the asphalt. That's going to be hotter. But when you get downtown, there's no vegetation to cool the air down. There's no shade. All this surface is doing is heating up. Oh, and we have a bigger graph. We could have looked at that one. Ha, LOL. All right. So where there's more vegetation, there will be generally lower temperatures. All right. This is a microclimate. This is a microclimate, so a small area. All right, and human activity has influenced the average temperature. All right, so let's look at this pretty little map. This map shows up a lot better on the computer screen than it does the projector, so good for y'all. Temperature distribution in London, August 2003. Dark red means really hot, 19 degrees Celsius, which is really crazy hot for people in London. They can't deal with that. They just can't even. Okay? Yellows and greens are cooler temperatures. So dark green is 8 degrees, lighter greens are 9 and 10. So if I look at this map, I can tell which places are hotter. Obviously, like this part right here. This is called Southwark, London. So that's all in this very dark red. Now Havering, which is over here on the very far right, if I look at the temperature of Havering, especially over here, it's substantially cooler. So what can that tell me about those places? I'm letting you guess now. I'm going to guess that because Havering is cooler, temperature-wise, there's probably more vegetation out here. It's probably less urbanized. Southwark, here in the very dark red, is very warm. I bet Southwark is more urbanized. It probably has more pavement. And let's take a look-see. Whoop! There you go. Have a good day. All right. So here's the River Thames. Here's Southwark. It's a very dense urban center. Look at how very little vegetation there is. Like, that's a soccer field. Or, excuse me, a football field. I'm sorry. Football. Excuse me. All right. Or some field. All right. Maybe that's another field over there, like a park. But there's no, like, grass anywhere. There's a little bit. There's no trees. There's no shade. It's all paved surfaces. Now, if we look over here at Havering, at this lovely stock photo that I found, this is still predominantly farmland and pasture. All right, so lots and lots of vegetation, very little pavement to absorb heat. This is where it's going to be cooler. This is not. Now, changing temperature is kind of concerning. In areas where it's really hot, like in urban areas, pollutants tend to be more concentrated. So the air quality is generally lower in urban areas because of that. So when we talk about problems, we want solutions. So let's look at possible solutions to runoff. All right, remember pavement is impermeable. So how can we fix that? All right. So first, this won't solve the runoff solution, but properly disposing of chemicals. So instead, when you're changing oil, making sure that it ends up in the right spot and not on the ground. Reduce paved surfaces. So in some newer neighborhoods, you might see driveways that look like this, that are like little stepping stones with grass in the middle. So you would pull your car up here, the tires on this paved surface. This is reducing this area, this little strip of grass. All right, that's going to allow for some more infiltration. And lastly, the coolest one, pervious concrete. So China has a massive problem with runoff due to urbanization because they are quickly growing. So their president a few years ago actually made this really, really cool. He put forth this initial program called 100 Resilient Cities. And I would highly recommend you look that up. That's a snazzy little article you could read. But as China is continuing to grow and become more urbanized, they are making an effort to make cities more like sponges. So they have pavement that water can soak into. And it feels different. It acts different. It's kind of cool. All right. But that's one thing. All right. So when you build something new, maybe look into these new materials. Possible solutions for heat islands. Because I can't change like where the sun is, but I can change the surface. I can change the covering of the ground. So planting trees, vegetations, and green roofs. So in some places this is more common than others. But if you've been to a big city or seen like TV shows about big cities and you see like the people running up to the rooftop or whatever, the bad guy being chased by the good guy, whatever. Normally it's just all concrete and pavement. But a green roof is essentially that. It's where you plant vegetation, like little patches of grass and whatnot. And it creates like a lawn basically, kind of like a suburban area. So this is kind of a win-win for everybody because not only do you get the reduction with the heat island, which is good, your air becomes healthier, but also you have this space that people can utilize. All right, if you lived in like a city, you don't have a front yard to play in or a backyard to play in, but this would lend that opportunity to you. All right. Having less pavement, just like those ribbon driveways, or lighter color pavement so it doesn't absorb as much heat. Using things like white colored roofs on houses and buildings. Again, lighter colors reflect heat instead of absorbing. So these are just some solutions. All right. So the runoff and the heat island are two environmental problems. There's other problems associated with urbanization. And again, some of these are pretty basic, straightforward. Because you have a whole lot of people in one spot, they're demanding more resources. So you end up using more fossil fuels. And we don't want to use fossil fuels as much because they're non-renewable. They cause air pollution, they make CO2, and that's something we want to avoid. They can worsen air pollution, increase your health problems because you're so close together. They can increase things like traffic and crime, which is just a byproduct of what happens when you have a whole lot of people in one area. So these are problems caused by urbanization that need solutions, and that is what your job will eventually be when y'all become big people. So even though there are many problems associated with urbanization, it is a part of our growing society. It's not like we can all go back and live on the farm. So going forward, we need to be more solution oriented. Okay, sweet. So here's your to-do list. Now that you've taken those notes, you can go back through, identify your key points, main ideas if you're in honors. If you're an academic and you have this all on the outline, go back and highlight the important things. Write 2 to 3 questions about urbanization that could be on a test. So prediction questions, don't make them all just like, what is? Make them a little harder than that. And then work on your Tale of Two Cities assignment. If you need help with that, you can come see me, and I'll be happy to show you on your merry way. Have a great day, guys.